Yeah. So address of the slave, which is 01 all the time when you're talking to a fixed PLC from a laptop. Function code, uh, that you'll see later on. Count is the number of bytes. Your number of data bytes. So number of data bytes you're sending. Yeah. So in this case, 1, 2, 3, 4. So count has to be 4. Yeah. So yeah, this is the count of the data you're sending. And then you have to have the CRCs. You actually got to calculate the CRC of all this packet. You have to do CRC 16. We'll have a separate video how to calculate that. Yeah, it could be a tricky, to some guy it could be a little tricky how it really works. But then I recommend you check out some other resources how CRC 16 is calculated. So you calculate that you'll have to plug zeros and zeros here at these 2 byte locations, and then calculate CRC 16 of uh, entire packet inside entire byte byte array, and then you have to place the CRC's low byte here and the high byte here, most significant byte here and least significant byte here, and then you got to fire this to send it over to the PLC, and then PLC will send you the values. These are the things you got to be little you got to be informed about, that these are the data types: input registers, coils, input discrete. Yeah, means input registers are like they're read only. This is something very important. While writing drivers, you got to be using it a lot. So just pay attention to it. Once, what really happens is that if you want your protocol to have a large set of memory address, then you'll get large numbers, right? Large number for large memory addresses. But you don't want to be sending large number over the wire, because that'll be dumb. You want to be sending, so that'll not be smarter. So what they do is that they have given a base address so to all the types of registers. So every time, and so these are the offset values that you need to deduct when you really really want to send it over the wire. uh, I don't know how to say that. Imagine from the PLC program, you really saw that the Modbus address that really you want to say read is say some value after some offset value after that. It could look something like say 564, yeah, 654, sorry. So you don't have to add send 3056, sorry, 30655. Once you add this number, that's the number you're gonna get. So you don't have to send that number. Instead, you have to subtract 3001, because that is the base address for that type of that type of type of memory that Modbus has. So, and that really saves you from sending big memory addresses over the wire, and that, so you'll just send 554, means hex equivalent of 564, and that really saves you from sending this whole number, which probably would be 3 or 4 byte long. Now you're just sending 1 byte memory address number. So these are the offsets, and you got to be deducting these numbers to the real number you'll get from your after converting your variables of your PLC program, you'll get a big number. And if you are doing input register, you'll get a number something bigger than that. So you don't have to send that number over to your slave. Instead, you have to deduct this number and then send it over to the slave. Yeah, this is what it means, that these are the base addresses, and all the values inside the memory map, all those address values inside the memory map are offset by these values. So you'll see it while I'm writing, while I'm sharing the actual drivers. This is input, this is read only, and this is the offset address. This is analog input. These are 16-bit wide. This should be read only. Coils are like read and write. It could be an relay that you are trying to set on and off, and it could be a memory bit, which is something I understand. I mean, that if you are a PLC programmer, you understand all that. Yeah. So the offset is 1. So and digital output is 1 bit, again read and write. Discrete input is read only. You can't really give it a value. Offset is 1 triple 3 times 0 and 1. This is digital input, single bit. Output register, it's also called holding registers in Modbus jargon. This is read and write again. This is the offset, and this is digital out, means you can read and write. Yeah. Hey, sorry, this is not digital out. This is analog out. Come on. Sorry. Oh, this is analog out. Okay, and this. Okay. There's a lot to be covered. Yeah. Well. This is an example of a request and response. Let's take a look and try to decipher what it really means. This is a request packet, yeah, and what it really means, hey, let me write it like this. Yeah, let's take a query and try to understand it. And once you have a clear understanding of the subject, writing drivers will not be a problem at all. It'll just be a matter of writing it inside the software. So if you are somebody proficient in software, I mean, you can really write it pretty easily. That's not a problem. At least it should not be a big problem if you've got an understanding of these things. Yeah. So the problem at hand is that I am trying to get. The question is, or the problem is that, hey, I mean, go get analog output holding registers from 4018 memory number to 40110 memory till 40110 memory address from device 17. Yeah, so this is the problem, or this is something we want to accomplish, or this is something we have to write the driver for. So we want to read the analog output or the holding registers values starting from memory address, Modbus memory address 40108 to 40110. So we've got so many locations to read from, and which is this device we are trying to read from? The device is number 17. So this is your this is in decimal, and we'll have to write it in terms of we have to convert it in hex, and we have to also write corresponding Modbus packet for it. So the start address is this number 40180 yeah, and like I said, every time you see holding registers, you have to, where are holding registers? It's here, Every time you see a holding register